All right, welcome everybody. And today we're going to be talking about in organic chemistry. We're going to be talking about cis-trans versus EZ naming for alkenes or just molecules with double bonds more broadly. So these are very similar naming schemes, I guess, but there's just basically one important rule that distinguishes them. So let's get started. So for cis-trans, basically the one thing about these is that both of the sp2 carbons of a hydrogen, of a double bond, so right here and right here, for example, those both have one hydrogen bonded to them, right? And so that is very different than the EZ, where they can have either one hydrogen or no hydrogens at all bonded to them, right? And so that's when you use cis-trans, is when you have both sp2 carbons with a hydrogen on them, right? Perfect. So that's what we see here in these top two examples. And then for EZ, it doesn't matter. They can either have one hydrogen or none at all. So once you've worked that out, and again, we're ignoring stereochemistry, and remember that for this one, you might think that intuitively there might be a hydrogen there that's just not drawn, but there's not, because we can see that this carbon, for example, has 1, 2, 3, 4, right? Different electron domains, and that's all carbon wants, right? Because then it has an octet. All right, and so then we can basically just follow the 1, 2, 3 rule for naming and deciding E or Z. So for a little background, though, cis, these are both Latin naming, schemes again, I'll call them. And cis is basically when the two groups with the highest priority are on the same side of a double bond, right? And then trans are used on the opposite side of double bond, like this. And these are actually used in biology as well. But anyways, so for this instance, I just gave it away, but this one is going to be trans, because we can see that this carbon has the main electron group down there, and this one has it up there. And this one will be cis, because, again, this sp2 carbon and this sp2 carbon both have their big electron groups, or their highest priority substituents, on the same side of the double bond, right? And so then this one, what do we think? Well, we can see that there will be a hydrogen there. Even though it's not drawn, we can count our electron domain. So 1, 2, 3, and then there has to be that fourth one there, right? So that's a giveaway there. And then same thing for this carbon right here, basically. And because the hydrogens are probably the lowest priority group that you'll ever see, you can just look at the other groups on this one. And we're going to see that this is an ethyl right here, right? And then this one, it's a, we have 1, 2, 1, 2 carbons, and then an alcohol. So that's an ethanol, right? And it doesn't really matter what they are, as long as we just know that they're on the same side of this double bond, because the other two ones are just hydrogens. So this one is going to also be cis. Now, moving down here, we have two different molecules again, but they're also similar. So in this instance, you want to look at them at the sp2 carbons one at a time. So this one, we have bromine and a methyl group. And on this one, we have an ethyl group and a hydrogen, right? And so this one is going to be 1, and this one will be 2, right? Because the way you look at these is based on atomic number, and bromine is way higher than the carbon for the methyl, because you look at what's actually bonded to the sp2 carbon there. And then on this one over here, again, the carbon right there is actually bonded to that carbon, central carbon, sp2 carbon there. And then the hydrogen, of course, is going to be lower. All right, so this one is actually going to be Z. And Z is just when both groups are on the same side. All right, and then for this one, basically, we just want to follow the same approach, of course, and we see that, again, this one actually happens to have 0 hydrogens bonded to the sp2 carbons, so we know that this one is going to need the EZ naming. And again, this carbon here has the same substituents as this example over here to the left, so we know, again, this is going to be the highest priority. And then down here, on this right carbon here, this is when we need the 1, 2, 3 rule. So basically that is where you just look at what the first substituent, or the first carbon or first group of the substituent is bonded to. And since we see that this sp2 carbon there is bonded to both a carbon and a carbon, we have to look at what's bonded to those. And we have a hydrogen, for this one, we have a C, and an H. Carbon, carbon, and then the hydrogen's in there. And this one, we have a carbon right here, and then 2 hydrogens. And so we can cross out that one, and then the next highest priority is the carbon right here. That gets precedence over that hydrogen, so then this group is the highest. So this one is again going to be Z.